Hello pre-calc people. I am making this video because you guys seem to kind of struggle with solving trig equations. So I kind of want to walk you through just the 3 problems that you could have done to buy back some points. So the first one was a tangent, just coming up with a general solution, and then the particular within 0 to 2 pi. So always you want to isolate your trig value. So we divide by 3. What you do need to realize, this is equivalent to 1 over rad 3, and it is positive. So that means the equation, or the solution, as a principal value would come from the first quadrant. And because tangent really only has one answer, because the other answer will be pi later, you just have to know what that solution would be. So one way to help you is to know that tangent is sine over cosine. So you see a 1 over a rad 3. Well, this is equivalent to sine 1/2 and rad 3 over 2, where the 2's would cancel, and sine of 1/2 is 30 degrees. So that means our solution is going to be pi over 6 plus pi n, and from 0 to 2 pi, the answers will be pi over 6 and 7 pi over 6. All right, so it's important you know your trig values. This is one reason why I don't like rationalizing, but that would be that answer. The second one, people struggled with this up to a point. Everyone got it at one point, and then things kind of fell apart. So again, you want to isolate your trig value. So the first thing we're going to do is divide by 2. So anytime you see rad 2 over 2, you should be thinking it's some sort of a 45-degree angle. Okay, so we still have theta plus 20 on this side. And then we have the inverse sine of negative rad 2 over 2, but we want a general solution for that. So since it is negative, the principal value is going to come from the pre-first quadrant. So you're just going to call this negative pi over 4. Or, sorry about that, this one actually is in degrees, so we get to actually say just negative 45 degrees. Where else is sine negative? It's also negative in the third quadrant, so which would be equivalent to 180 minus the negative 45, which would equal 225. All right, so our answers here are going to be negative 45 degrees plus 360n and 225 degrees plus 360n, but we're not done because we have theta plus 20. So I still have to subtract 20 degrees. Notice I had split this up into 2 equations because you now have to subtract 20 degrees from each one of these individually. You can't do it as just one equation anymore. And so what you get as a final solution is negative 45 plus a negative 20. So that's going to give you negative 65. The 360n doesn't change. And then 225 minus 20 is going to give you 205 degrees plus 360n. So that is going to be your general solution. Okay, so again, people sort of fell apart here. So realize you have to break it up into the 2 different quadrants, the principal value, and then 180 minus that, wherever else sine is negative in this case. So we have here theta equals negative 65 plus 360n, and then 225 minus 20 degrees is 205 degrees plus 360n. And since our answers are between 0 and 720, if you wanted to, you could set up your chart So when n is 0, oh great, sorry, you're going to have, I have no idea if that text is going to come out on this video or not. Oh well. If n is 1, so you're going to keep adding 360. So this becomes 295, this becomes 565, and if I keep going, when n is 2, I'd be adding 720, but at that point, you know you're going to be out of range because it's only 0 to 720. So when we gather up all our answers that make sense, this one is not in the right range. So we start with 205 degrees, then we go to 295 degrees, then we go to 565 degrees. So you have, oh, actually I am wrong. Excuse me for that. If I add another 360 to that, that's 5. That is actually going to give me 655 degrees, which is still within our range because we started at negative 65. So you'll have 4 answers here, 655. All right, so again, isolate your trig. You're going to need to know your trig values. You need to know those principal values. So a negative sign comes from the pre-first quadrant. That's a negative 45 degrees. Then 180 minus that gives you in the third quadrant the 225. But then you have to subtract 20 from each of those individually, and it's still 360n. Okay, then we get to our last equation. So notice it looks like a quadratic, but you have 2 different trig. So you're always going to want to transform the one that is squared because you can use your Pythagorean property on that. So sine squared is going to become 1 minus cosine squared, and then we're going to want to simplify that. So that's 2 minus 2 cosine squared plus cosine x minus 1 equals 0. So I'm going to combine my constants, which gives me 2 minus 1 is a positive 1. And then when I factor, I don't really like a negative coefficient. So I'm going to multiply everything by a negative 1, and it gives me this. So to factor that, it's going to become, in parentheses, you know this has to be, to get a negative 1, 1 will be positive, 1 will be negative, but you know there's going to have to be a 2 cosine x and a cosine x. That's the only way you can get the first term. So I do the little double rainbow thing. I know I want a negative 1, which means I want my bigger number, whoops, how do I do the backspace? Okay. So I want this to be a negative 1, so that gives me a negative 2 plus 1. So this one becomes plus 1. That is going to give me a middle term of negative 2 cosine plus cosine is a negative cosine. Now we set each term equal to 0. So I'm going to do that over here on the side. So I know that 2 cosine x plus 1 is 0. So cosine x equals a negative 1/2. Where does that happen? Well, let's think about principal values again, because that's like saying x equals inverse cosine of negative 1/2. Cosine for a principal value comes from the second quadrant. So, however, you are allowed to then say plus or minus 2 pi over 3 plus 2 pi n. So that's going to give you this answer. And then our second factor is going to be cosine of x minus 1 equals 0. So cosine x equals 1. That's going to be one of your quadrantal angles, which is right here. So that case, you can just say 0 plus 2 pi n. Whoops, getting close to the edge there. So change my color, that's fine. And then we want to give all our solutions in the correct range. So you can either do a table or a map, as I've done sometimes. So n equals 0, that's our 2 pi over 3, negative 2 pi over 3, and then we also have 0. Hopefully you realize if it's 0 plus every 2 pi n, and we're giving an answer from 0 to 2 pi, those will be your two answers. 2 pi over 3 is really going to be the only answer. I actually personally like to do the little math thing. So you have the plus 2 pi over 3, you have the minus 2 pi over 3, and you have this and 2 pi. So those are your only answers. So we are going to have 0, we are going to have 2 pi over 3, we are going to have 4 pi over 3, and we're going to finish with 2 pi. And I get the negative 2 pi over 3 by adding 2 pi, which is the same thing as 6 pi over 3. That gave me 4 pi over 3. So those are my answers. Okay. So it's really important that you kind of be careful with your algebra, you know your principal values, and then just doing your common denominators to get them all together. Okay? I hope this helps.